Ladies and gentlemen, adding probabilities, lesson 5.8. Your learning targets for today, you should be able to find probabilities of more complex events by creating a list of all possibilities and determining the number that are favorable. Also understand and use complements of events. So let's dive right in. A little bit of probability review here. The probability of an event happening is the number of favorable outcomes out of the number of total possible outcomes. Just a quick review for you. Two things that we do need to discuss. We do need to discuss this idea of mutually exclusive events. Mutually exclusive events are events that cannot happen at the same time. There is no overlap. There is no option that, oh, both of those could happen at the same time. We're just looking at that they cannot happen at the same time. In this case, for our counting, simple addition will work. It's pretty easy to do some simple addition to find the total favorable events. A couple of examples of mutually exclusive events. Having Ms. Trundle and Mr. Voller as a teacher. You wouldn't have both Ms. Trundle and Mr. Voller as a teacher because they both teach social studies. And you wouldn't have two different social studies teachers. So this would be a mutually exclusive event. The fact that the lamp, your desk lamp, is both on and off is mutually exclusive. It cannot be on and off at the same time. It's definitely one or the other. Being in elementary school and high school at the same time, that's definitely a one or the other. You would not be in both at the same time. If I roll a pair of dice like the one that you see down here in the corner, the chances of me getting an even sum and getting a sum of 7, those would be considered mutually exclusive events, because if my sum is even, it can't be a sum of 7. So we can't have both in this case. It has to be one or the other. If I've got a 7, it's definitely not even. And if I've got an even, it's definitely not 7. If we have mutually exclusive events, we also want to consider non-mutually exclusive events. This is pretty much the opposite. These are events that can happen at the same time. There is some overlap here. Simple addition will not work. In order to do this, we're going to have to do some careful counting. Often with a picture is probably the best way to go. Some examples would include having Mrs. Reba and Mr. Casper as a teacher. One student that you guys may know, Ben Anderson, he's an example of this. He has both myself and Mr. Casper as a teacher. Playing soccer and playing hockey. These are not mutually exclusive events because you potentially could do both. You might know someone that plays soccer and hockey, or you yourself might play both soccer and hockey. If we go back to rolling a pair of dice like the one that you see down here, getting a pair and getting a sum of 4, this is not mutually exclusive, because if I get a pair of 2s, I've got a pair and I've got a sum of 4, so I have met both qualifications. So again, non-mutually exclusive events are those events that can go together. I potentially could have both things occurring in one instance. The last vocab that we're going to cover here is the complement of an event. Complement of an event. As we take a look at the complement of an event, we're including all outcomes that are not the event themselves. Essentially, we're saying here's the event. I want everything else. It's all the other possibilities put together. So here are a couple of potential events. The probability of snow could be 40%. The probability of Ricky Rubio making a free throw based on his relative frequency, based on the data, is 76.9%. And the probability of rolling doubles on a pair of dice, there's 6 of those. A pair of 1s, a pair of 2s, a pair of 3s, a pair of 4s, a pair of 5s, and a pair of 6s out of 36, which simplifies down to be 1/6. We can talk about the complement of this event. That means anything else. So when we talk about the probability of snow, anything other than snow would qualify. We could talk about the probability of rain, sun, sleet, cloudy, anything but snow. A quick way to incorporate all the possibilities is just to say the probability of not snow. That would be everything else. And so since we know there's 100% of possibilities, the snow takes up 40%, everything else, the not snow, would take up the 60%. So if the probability of Ricky Rubio making the free throw is 76.9%, and we want to know the probability that he does not make the free throw, that would be the complement. The complement just basically incorporates that word not. We would take, well, what would it take to give the other portion to complete the 100%, it would be 23.1%. If I add the two probabilities together, I'll always get 100%. Now, probabilities are not always given as as a percentage. We can also see probabilities as a fraction. The probability of rolling doubles, the complement of that event would be rolling anything that is not doubles. So we could get a 1 and a 2, a 1 and a 3, a 2 and a 4, anything that is not doubles. Rather than listing out all those options, again, we just use the word not. So the probability of not rolling doubles on a pair of dice, we look at all of the other options. So if we're considering out of 36, it would be 30 out of 36. If we are considering the simplified form, it would be 5 out of 6. So right now, what I want you guys to do is to think a little bit about these next couple examples. Consider the English names of the 7 days of the week. What is the probability that the first letter is an S or the last letter is a Y? So we need to consider everything that begins in an S or that ends in a Y. For the next two questions, you may want to write out the event that you're looking for. So as I was saying, for the next two, for number 2 and number 3, you may consider actually writing out the probability event that we're looking for, because in a moment I will reveal a slide that shows you all the possibilities for your 52 card deck. I know that not everyone's super familiar with a card deck, so I can show you all the possibilities, and I can also show you all the possibilities for rolling 2 dice. So go ahead, press pause, write out the 2 events that you're looking for. The probability of drawing a king or a heart, so either one would work. The probability of drawing a face card or a black card, so again, either one would work. And then in number 3, the probability of rolling a 2, so getting a 2 somewhere when you roll, or that the sum is 6. So either one of those would work, that you could get a 2 or a 6. Again, if you're not all done writing that out, press pause now and go ahead and write it out, and I will reveal all possibilities to help you determine the 3 probabilities you just wrote down. Here are all the options for a deck of cards on the left and all the options for rolling your 2 dice on the right. Use this to help you answer those questions we will be discussing in class next time I see you.